So the next problem I want to do is number 5, and the reason I want to choose 5 is, first of all, if you read the directions here, it just says trial and error at the end. So what's happening is we're being given the initial velocity, just like we've been given before, but now we're being told how far from the cliff, in this case, how far from the initial point the object hits the ground. So we need to find how high the cliff is, and in order to do that, we've done one like this in class, but you can do it algebraically, but I'll show you first how to do it using the trial and error method. So let's go with, there it is. Alright, so our drawing will look a little something like this. Got our cliff. We now know this is 60 meters. Say, and we're being told 19 meters per second. So h is our unknown. Alright, after we set up our diagram, the next thing is our vectors, so our x1, y1. And in this case, we're still just working with a horizontal initial velocity, so 19 times t. So I'll put that right in there. But with our y1, we still don't have any vertical component to our initial velocity, but we also, in this case, we don't know how high above ground we are. So we're going to leave that as h, and then we have our gravity. So we'll put that in. And from here we're going to put into our calculator our x1, y1. So let's do that. 19t. And okay, here's where the first thing we need to do is say we can't put another variable in there, and we can't call it t. So I'm going to start with, I'm just going to throw a number in there, 10, so that I can continue my equation, minus 4.9 t squared. Now, here's where the trial and error is going to come into play. We'll set up our window, and we'll still use 0 to 5 seconds. Again, we'll start with 1/10. Later we can, if we want, we can move to hundredths. Our x min, x max. Now here's what we know about the problem. We now actually know exactly how far we need to go. We need to go 60 meters. So I'm going to set that to 60. Now, here's the tricky part. With our graph, we want our parabolic curve. Let me draw it out for you. We've basically just enclosed in our graphing calculator. We've just set our window to something like this. We want the graph to look exactly like that, so that this dotted line that I drew, that part of that curve that we see, we want that curve to hit the x-axis exactly at the end of our window on the right hand side. So in order to do that, as we change our h, our y-intercept, as we do that, this curve continuously moves up and down. Okay, so if we keep changing that h with specific numbers in mind, that's the trial and error, is changing the h value, which I put in as 10. You keep changing that 10 to be bigger or smaller until your graph ends up in that bottom right corner. Once you get that graph to be ending right here in the corner, then whatever h value you used answers our question of how high is the cliff, because that's what h is. So here we go. We're going to graph, make sure we have that in, 19t. So we clearly need to raise that up, so let's go drastic here. Let's go to 100. Whoops. We're going to need to change a few things. 100 insert a minus t squared. Here we go. Alright, so that was a little too much. Using the bisection method, that's something you'll learn in either Calc 1 or Calc 2. Bisection method says in trial and error, if you start by taking half of the answer that you think it is, if you just keep going from one side to the other, taking half every time, you're going to find your answer quickest. So we just took it from 100 to 50 divided by 2, and we're still not right. So we're going to take that to 25. And okay, now we've gone too far because our graph was up here, so we were too high. Now that we've moved our graph to 25, we can see that we're too short. So I'm just going to go, at this point you just kind of use that guess and check again. Raise it to 30. We can go to 40, see if that's too much. Okay, 40 is closer. Using that bisection, we know 50 is too high and 40 is too short. So we go halfway. So we're getting close. It's got to be around 48 feet then. There. If we go 49, alright, so let me just show you too our y min y max here. See, our y max is from that problem before, problem 2, where you're just shooting an arrow from 1.5 meters. So I actually should have changed that. I'm going to change that to 50 now, and you'll see what happens there. That's actually a lot better representation. I apologize. I should have changed that y max sooner, because what I can do now is I'm going to change 49 back to 50. Okay, so actually 50 was pretty close. Let's go one more, 51, see what happens. Alright, so you can see that it's very, very small detail, but the graph does actually go past that 50, or that, that 50 mark. So I'm going to say our height, should be 50. Alright, so let's go ahead and do that. We're going to say h is 50. For the purposes of making videos as short as possible, I'm going to stop this video here, but what I'm going to do is I'm going to pick up the next video right from this spot and show you how I would do this problem using algebra instead and getting the exact height instead of just estimating 50.